In this lesson today we're going to be looking at the systems life cycle. We're going to be looking at the different stages and we're going to be learning what way they work. The first thing that happens in the system life cycle is a preliminary investigation. The things that you need to learn about this is the feasibility. Now there's five different types of feasibility that you need to know. They are TELOS. They are technical feasibility. Is it technically possible to solve this problem? Is the hardware there? Is the software there? Is it available? Economically is all to do with money. Is there money there? Will it save money? Is there money to continue the project? Legal is, will it break any laws? Will it break the Data Protection Act, Copyright Designs and Patents Act? Will there be licenses available? Operational is also known as social. This means, will the system be operational? Will staff be willing to use it? What will be the impact? Will there need to be staff training? Will there be redundancies? And schedule is, will it be delivered on time? Will it meet the schedule? And to do this, they usually use a Gantt chart. After you've carried out an investigation to see what is, at the end of it a feasibility study will be produced. If they decide to go ahead with the project, they'll need to analyse the problem. Analyse the problem consists of fact-finding. There's four main fact-finding things that you will need to look at. The four main fact-finding methods are, again you'll need to know the advantages and disadvantages, and you'll need to learn the definitions of these. Questionnaires and surveys. Okay, these can be given out to a large cross-section of users at the same time. They can be very quick for gathering a large amount of data from a large amount of users. Again, a disadvantage of them is you can't elaborate on their answers, and again it's difficult to know who to survey. Another advantage of questionnaires and surveys is they can be used to do graphs and statistical models to back up your claims. Again, interviews. Whenever someone's getting interviewed, they might feel under pressure. This is a disadvantage of interviews. An advantage is, however, they're able to elaborate on their answers. Again, you can custom make your responses based on what they're saying. A difficulty with interviews is picking the right person to interview and getting the right questions. Observations. Whenever somebody's being observed at work, they might act up. This is a disadvantage of observations. However, it's very good at seeing firsthand the problems that exist and how the day-to-day workings work. Lastly, you need to examine current work documents. Now this is very good for looking at the inputs and the outputs that take place in the organisation. It can also maybe, a disadvantage of it is you might not be able to see all the problems by looking at the documentation. So here is a past paper question. Again, I'm going to show you the answers in a second or two, but notice the level of detail required. So you have to state one benefit and one drawback for each of the following methods. So observation. Again, for an observation, the benefit is the working of the system can be studied first hand. The disadvantage is users might act up. They might act suspiciously whenever they're being observed. It's difficult to select the users who do observe. Again, questionnaire. If you're stating the benefit, the same set of questions can be given to a large cross-section of users at the same time. If it's anonymous, they might elicit honest answers. A drawback is the questions have to set beforehand and cannot be changed in response of the user's responses. They're not flexible. Interviews, again, the interview can be fine-tuned to the user or follow-up questions can be asked. The disadvantage is, again, the user might act up under the pressure. It might be difficult to select the users to interview. Again, for this question you really need to learn the advantages and the disadvantages and be able to elaborate on them. No waffling allowed here. After you've carried out the analysis, the next thing that you're going to do is design the system. Now, what you need to understand about this section is the main documentation required. So you'll need to know the 6 main design documentations, if that makes sense. Now, the 6 main documentations include the data dictionary. This is defining all the tables. You've got the data flow diagrams, you've got the Gantt charts, you've got the PERT charts, you've got the ER diagrams. In addition to this, you have to design the inputs. Now the inputs would be the forms that you would design whenever you're doing your coursework. Again, you have to design the outputs. These would be the reports that you would design whenever you're doing your coursework. You've also got the human-computer interface design. Now this would be the menus that allows the user to communicate with the computer. And again, this would be your switchboards, designing out what your switchboards look like. You've done this in your coursework, you have to memorize this. Another thing that could be in it is the test plans. And again, another thing that is really required is the hardware and software requirements. What hardware is required to run this program, what software is required to run the program. After you've designed the system, you're going to maybe test it and you maybe implement it into the company. Now, what you need to know is you need to know the two different types of testing, especially the AS level. Now, the two main types of testing are application testing. Now, this is done by the developers. It's very important that you understand that. The developers with specifically chosen data. Different types that you need to understand is that each unit will be tested alone. You're then going to do integration testing. This is testing the units to make sure that they communicate together. And then you're testing the whole system. Again, you would need to memorize unit, integration and system testing. These are the level of detail that's required at AS level. You may be asking, what are the specifically chosen data that developers will test? Well, the data is right data, wrong data and extreme data. They are the three possible test scenarios that the developers will test the system with. Once the developers have tested the system, they'll maybe pass it over to the end users. Now, the end users is acceptance testing. So once the system is tested to satisfaction, it's passed over to the users who will conduct their own tests with real life data. They will continue testing until agreement is reached, and again, just notice the end user involvement here. If we go back to the system lifecycle, it looks something like this. You'll see that the end users involved in the feasibility and the analysis, gathering up all the facts about the problem. They're not involved in the design. The only place that they're involved in then is the testing, so they're not involved in the design at all. After it's designed, it's going to be implemented into the company. Now there's four main changeover methods that you'll need to know. The four main changeover methods include this. Direct. Direct is where the old system is discontinued and the new system introduced simultaneously. This means that you stop using the old system one day and you directly go to the new system. The advantage of this is there's no duplication of effort, cost or time. However, if the new system fails or doesn't work as expected, there's nothing to fall back on. So if you imagine you're using a paper-based system, you directly start using a computer-based system, but the computer-based system fails, you have nothing to go back on. Another way of overcoming this is parallel. Parallel is where the existing system and the new system work together until the new system has been proved. The advantage of this is, if the new system crashes, the old system is still running, so you have something to fall back on. Again, you can also check the output to compare them to make sure that the job's working correctly. A disadvantage of them is, you have to pay for two people to run the old system and the new system at the time. There's a duplication of effort, cost and time, people's time. Other ones that they might ask you about, but I don't think you really need to know them as much, include pilot. Pilot would be like a pilot TV show. This is where a group of users access the system first, and any errors can be dealt with, and they give feedback. So they give feedback about the system before it's introduced to the whole company. Another one might be phased. Now this only works in large organizations. So the changes takes place in small stages, one at a time. Again, if I was doing this here, I would learn the highlighted bits, so be able to compare direct and parallel. They're the main ones that you really need to know, and there's a lot of advantages and disadvantages that you can write about. So this is a system life cycle. After it's been installed and stuff like that, the last thing that might occur is maintenance. The whole reason for having the system life cycle is it's well documented. At the end of each stage, there's some documentation to help with maintenance. Now, maintenance is where problems might occur. There's three main types of maintenance that you need to be aware of, and I think of Pac-Man whenever I do this. The three main types are perfective, making the system more perfect, making it more efficient, making sure that everything works the way that it should do, and any desirable add-ons are working. Again, that's very important to highlight that. Perfective is to do with the efficiency of the system, the loading up times, things like that, making it more perfect. The other one is adaptive. Now this is where the user's needs have changed. So the VAT rate might change, or interest rates might rise. The business needs to adapt the software because of these new needs. The last one's very simple, it's corrective. It's where there's bugs found in the system and you have to correct them. Again, notice the key words there. Perfective, making it more perfect. Adaptive, adapting to the new user's needs. Corrective, correcting any bugs or errors found on it. Again, past paper question might say corrective maintenance needs to be performed, name and describe two other types. So this is where you have to understand perfective and you'd have to understand adaptive and be able to explain them. So that's the systems life cycle. Again, once it's all done, this is what it looks like. Again, you've got the feasibility, you've got the analysis, you've got the design, the development, the implementation, and the maintenance. If you were asked to describe this, this is how you would describe it. You would say that there's a number of discrete stages. So feasibility, analysis, design, development. A number of discrete stages. At the end of each stage, something is produced, and each stage must be complete before you can move on to the next one. So the analysis must be done before you can move on to the design. Another thing you would say is there's an end deliverable. So at the end of this here, there's a feasibility study. At the end of the analysis, you've got all the fact finding. At the end of the design, you've got the design documents. At the end of the development, you've got the test documents, if that makes sense. At the end of each stage, there's also a review. You might return to a previous stage if you're not happy with the work in that stage. So they might return to a previous stage if any errors are found or agreement is not reached based on feedback. And that's the systems life cycle. One other thing that they might ask you about is the documentation. There's two main types of documentation. They are user and technical. Technical is very similar to the design section. So if you think back to what's contained in the design section, you'll remember that it's made for the developers and the technicians, and it includes the following: data dictionaries, the inputs of the design, the outputs design, the human-computer interface design, the test plans, the hardware and software requirements. The user documentation is made for the end user. Okay, it's got very simple language. They don't need to know all this technical stuff. They only want to know how the system works. So they'll need to know what hardware and software is required to run it. They'd want a list of contents so they don't have to read the whole document. They would have how to install the software, which is very important, so they can get it working, how to use the system, and then how to contact support if they have any problems. Things like frequently asked questions, or how to ring up a help desk, if that makes sense. So this is the systems life cycle. These are the main stages. These are the main things that you need to know. Again, they could ask you about any of them. Thank you for listening. Thank you.